Hello guys, I had a free time and I've updated the particle system, and in that video I would like to give some notes about this update. So first of all, I would like to say that there is the folder where I put some samples when I'm testing the particle system features, and this folder is inside the GitHub MB scenes GPU particles. So here are some examples of new updates. First, let's start with the snow we're seeing. So because it's a new year coming, and yeah, so this scene should be quite in place here. So as you can see, I've added support for rotation for particles and also the angular velocity. So the particles are generated, we can specify there is a new type of geometry which are quads. So we have a look from the right side, we will see that it's a really plain, so it's different from the billboard that was previously, or different from the points which always look at the camera. So quads, it's something that simple planes moving down, and we can specify the startup orientation. You can find it here in properties in particle generation, emit rotation. So this is the initial orientation of a particle. For example, if we put 90 degrees here, we will see that the particles now is oriented parallel to our floor plane. And we also can, this is the angular velocity, this is the velocity in time. It's you can specify degrees per second how the particles will rotate along the local axis. So we can increase in some axis, we will see that the particles will move very slowly. In some axis. So that's the rotation feature that I've implemented. And another thing that I would like to show is that now we have the point fell off feature. So this is the original texture, which this texture doesn't contain any alpha channel. So in that case, when we want to not have, for example, if we have points and we can point smooth, to have this one is a textured rectangle, so there is no point smooth actually. But anyway, point smooth is the when we have a color and the points are just rounded, but it's a hard edge. And point fell off helps to make something soft edge. So it could look sometimes maybe a little bit nicer, softer. So anyway, this is the one thing. Another thing, that by default we have one color, and we could assign the variations for that one color. But in many cases it's not very convenient to have this kind of variations. There are some situations when, for example, you would like to assign just a combination of 3 colors without too many variations. So we can make it with this new feature. We will use color 2 and color 3. So it will randomly select a new, when it generated and emitting a new particle, it will choose one of these colors to use as the current for the particle, and we can change these colors. We will see that the particles are just combinations of these 3 colors. And if we increase the color variation, that will be the color variation for each of these colors, actually. And now the size curve and the color curve, they are works as the multiplier. So for example, the color curve, by default, it's a color curve from the white color to black. This is the local lifetime duration for each particle. So the particles start from the multiplying with the white color, that means no changes. And ends with the black, as the multiplier is black, so every color goes to black. And also in this variation we could also select element, and this one is the alpha channel for the color, so we can, for example, decrease the alpha channel, and that will make particle makes it disappear, so we will go to this. So it looks also quite interesting. And yeah, if we make the black not so black, a little bit gray, it will look much more closer to the real snow as well. So there is no really texture of the snowflake, but anyway, it looks also not very bad. And we have this very slight cross fade out before particles goes out. Anyway, this is one thing. Another thing that I would like to show here, let's go to scene with a mirror. So it's a scene where particles are emitting from the mirror character. But what's interesting here that now in particle system I've added a feature to generate particles only on motion. And also there is the motion factor. So this is the velocity limit, and when so I've computed the changes between two frames of the deformable meshes, and when this change, this difference is length of this difference is greater than 1, the particle could be generated on that triangle or that surface, part of the surface. And as a result, we have quite interesting effect of part of surface which generate only on motion of the particles. So that's just an interesting effect, and that's all. Another thing that I would like to show here is the self-collision. So this one is in progress, but anyway, we already can have a look that and compare with just the original particle generated, because there is no by default there is no really any integration, any connection between particles. They are really no collision, no acceleration, no touching, nothing. So that I would like here to assign the last particle weight, let it be 100, and then I turn on the particle shader. So this is the default behavior of a particle system. There is no really any collision between particles, but we have this flag of self-collision. In that case, I'm running 3 shaders, one to prepare data for each particle, another one to compute acceleration and combinations between particles, particle to particle. If there is the distance less than 2 radius of each particle, it's accumulate the velocity to move out a particle from that area. Yeah, so we turn and we reset. Oh, perhaps we need not to use the per generator. Sorry, this one is this is just experimental feature, so not everything works well. But anyway, you can see here that the particles yeah, and now it looks really like particles have the radius, and they push out other particles, and it looks like tons of objects instead of just simply kind of liquid when everything goes inside everything. So if I turn off the self-collision, you will see that it's really big difference. The particles are just moving sound and move inside, and there is no feeling of physics of this behavior. And if we use self-collision, they're just pushing each other, and it looks much more interesting in that case. So that's the feature of self-collision, but it's a very experimental one. But anyway, it works. Even very quickly, we could apply the instancing. So we have this feature of instancing. If we go to type of instancing and just here in the instance object we should assign any geometry that we would like to render particle as. So this is the size very big one. We just make a less size, and we will see that in dynamic. Yeah, it's a self-collision. No, it's like a self-collision. Radius is too low, I think. So we need to have bigger radius. But anyway, when we have bigger radius, there is no really. We can make this one. No, this doesn't help. This one doesn't help. So we control with this radius, but anyway, when we control this radius, yeah, this feature is very experimental. So that's only if you have any ideas of how we can use this feature. I can update some parts of code, but anyway, just for playing. Another thing that I would like to show here is the experiment with like motor force. This one is the right now the motor force. It has a checkbox where you can switch between two states. With the previous, or that I called we can increase the rotation. Yeah, so previous it was like a motor force, the previous realization of the motor force, and the new one it's like a vertex. So return, rotate back, and put this keyframe, so it looks like it's a vortex. And it could control particles if they are inside the area. If they are inside the area, it will take the particles and vortex them. So that's the behavior. And also the previous force, which called if I remember correctly, it was the drag force. Now I rename it into the gravity force. And we have this point, so we could simply drag and drop into the particles to connect the force to the particle system. And maybe the influence right now is too much, so this is very touchy parameter. And we could use this force to change the it's like attraction force, gravity or attraction force. So we can manipulate where our particles will move, and also we could use the local influence radius to take on the part of the particles, not everything, but on the part of the particles. If we're here, we could increase and try to attract particles to this gravity point. Yeah. And also, if the calculation precision is not enough, we always can change it. In common settings we have this kind of iteration, so it's 30 iterations per second of the emitting and simulating. We can increase, for example, to 60, so there will be more precision in the calculation of our particle system, because it will be more times integrating per second, so it will be better quality of the particle simulation. Yeah, that's it. Very old example. It's a combination with a column play and particle system. This particle system I use in terrain collision. Terrain collision is something that very helpful. Like by default for particle system there are only two types of collision. It's a sphere collision and terrain collision. So terrain collision is the area where you specify the size of this area and you specify the elements which you would like to render as the derps from the top view. So that helps to the particle system uses these derps to collide particles with a height. It's like a height map, so it's used for particles to collide with the mesh. And this map even could be dynamic, like in this example, because these columns are dynamic. They could be connected to a microphone. For example, if I activate my current microphone, I will speak and the columns will play, and they will move the particles up. So that's probably the very good example of dynamic terrain collision. This is the constraint which control, and the columns, they are going up according to this curve. So if I move the curve, I will choose another columns which will move up. So this could be very useful for any kind of play, real-time play effect with these columns. Anyway, this is the example of height map collision for particles. So, and one more thing that I would like to show here is the emit animated chart. This is quite interesting example. So this is an example of instancing, but in that case I have the animated character, and I can play loop animation walking of that character. And all the instances are there, like they instance the GPU animated mesh, so we can even put the GPU skinning flag to have a good performance. And we have a lot of these kind of particles, and each particle has just a velocity to move forward without any damping. And we play animation, and each particle render instance of this animated character, but in different position and different color and size. So that's probably makes a kind of crowd effect when we have a look. Like right now the particle system support just one mesh, so that's why we don't have legs, but anyway it supports texture. And as we're using here 3 colors that I have shown in the beginning of the video, that we can specify 3 colors, and the particle will randomly assign one of this color. And then we have random from the generation, from this one shading tab, we have around 50% of size variation for that particle generation, and the particles moving forward without any rotation, but we could also apply any kind of rotation if needed. So this is also that interesting example of how we can use the particle system to do many instances of the GPU, even GPU skinning mesh. Alright, so that's the things that I was thinking to show in that video. As for other features, if I remember something, I will recommend maybe another video. Anyway, thanks for watching, see you in next videos, bye.